sometimes 75-ish. So what is that? This is a partially organized perpendicular zigzag structures. The space between that somehow 0.36 to 0.38 nanometer. Okay, what is going to be the beta looks like? What's the beta looks like? The beta will looks like is more organized. Go this way, go that way. So that's called a parallelogram. So go this way. It is parallel, so it looks like that. So very organized, you can see. So this is we call it a parallel packed zigzag stack. And this is a distance, space between that is around 0.32 to 0.34 nanometer. So we are talking about the food chemistry. So what type of the products it is? This right in the middle, the beta prime, basically is for margarines, shortenings, and also the cake. The beta form basically is the products had a high amount of the palmitic acids, let's say canola oil, or the butter. The cocoa butter is actually the beta form most of the time. And the beta prime, this is cake, margarine, and the shortenings. Now, when you choose an emulsifier during the food processing, it really depends on which form you need it. So, for example, if you're doing the margarine and the shortenings, this go back to this question. This is OW configuration related to the emulsion. So you need to using is an intermediate level of HBl because HLB because you want to keep its beta prime form. And like we said, you want the cake looks like a cake. You don't want the cake looks like a bread. It's very tough. And why it is important? Because the beta prime form will give you a shiny surface. They also will give you a smooth texture. But if you are going to be choosing something with a beta form, you need to make sure it will achieve the beta form's polymorphism. The reason is this is going to be greeny. Okay? And it is very important, especially you make a chocolates and using a cocoa butter. So why it is important? Chocolate during the quality control process, there is a one major issue will happen all the time. It is called bloom. What means a bloom? You see those white, greenish, cream, or we say fatty acids, the mixed products is showing on the top, showing up. So let's say black chocolate is no longer black, you see the white there. It's unedible. That's the reason if you didn't pick a good emulsifiers. Obviously, another reason cause bloom of the chocolates is use storage at abusive temperature for too long. Because we are very important, want to talk about this guy. What's a chocolate curve looks like, okay? Another curve we'll talk about, y-axis FC, x-axis will be the degree Celsius temperature. So what's the chocolate curve looks like? The curve looks like this. Okay, so let's talk about that. We talk about the polymorphism of the lipids. There's a different polymorphism, different morphology, alpha, beta prime, and beta. But what do we really care? Not only the morphology, we also care about the solid fat. How many solid fats there? So therefore, it comes out with SFC. Okay. Originally, it should be SFI. Solid fat index. Later on becomes SFC. Solid fat content. What's the difference between that? Different measuring methods. SFI, using an older method, we call it a dilaometer. You just measure what's the dimension expanded. SFC, you see the exact solid fat content because you're using a nuclear magnetic resonance methods. Okay? So what's the curve going to be looks like? This is a curve looks like. What's the temperature? This is suddenly go down. It's above 35 degrees Celsius. This could be go up to 45 to 55. This is important for the chocolate. The solid fat, if they lower than 35, typically at 25 degrees Celsius, this gives you solid and heat resistant status. Okay, and once you put in the mouth, it's going to start to melt it. What's the melting will be generated? It's a cooling feeling. Some of the chocolate, they even add alcohol, and they give you like a more cooling feeling about it. So that's why the solid fat components is important, and also the melting points is also important. I gave you another example. So there's another curve looks like this. This is what the curve looks like. Is taro. The taro usually melted at 50 degrees Celsius. Why? What's the good thing for that? They give you a waxy feeling when you eat it. Okay, so that's very important. Now, there is something else we want to mention. Remember the cocoa butter structure. Stereospecific number 1, stereospecific number 2, stereospecific number 3. The middle is oleic acids, and on the top is palmitic acids, and the bottom is could be stearic acids. Okay, if I change it, I took this out, or I let the oleic acids the amount which is decreased, then the curve will be changed. What's the chocolate curve will looks like? The chocolate curve could be looks like this, which means give you more tough, more greening results. It's going to be a new product, but somebody really like it because it's give you a hard biting feeling. So really depends. This comes out with another topic. I don't know whether we have time. Okay, we'll talk next week. This gives you another topic, which is called interesterification, which means triglycerides, they could be reacted with each other under the condition with catalyst. The catalyst has metal, sometimes combined with glycerol, and then they could change the stereospecific number 1, number 2, number 3, the glycerol components, and they later on will change the melting points of the products, and also could change the solid fat components of the products, and will let the texture characteristics will be changed dramatically. Okay, this we will talk about on next week Tuesday, since we don't have much time left. Okay, so that's all we have today.